So, our talk is about securing REST API endpoints against data leaks, or subtitled, How to Avoid Another Optus. I'm not talking about the Optus thing that happened last week. I'm talking about the Optus thing that happened last September, which I'll explain in a moment. Right. So, first of all, who am I? I call myself a security-interested software developer these days. I'm a dev, not a proper security practitioner, but I like application security, so I pay a lot of attention to it. These days, I work as an applications developer at 2 degrees, in case the drink bottle and the t-shirt didn't tip you off. I also have a PhD in computer science from university, and like Ben, I actually have an accounting degree. And for my one's actually real. I'm also on the InfoSec Discord a lot, and I'm told I excessively reference The Simpsons, so I just stuck that throughout this. Hopefully you can actually, hopefully you can make them out. Right, yeah, okay, so just a few things I'll go over first. So the focus here is specifically on preventing sensitive data leaking out via API endpoints. So, I mean, like customer, employee, personally identifiable information, which sadly keeps leaking all the time. I'm only going to be talking about REST and REST APIs / web apps. No GraphQL or gRPC in that, mostly because, hang on, something went wrong.
Yeah, blame Microsoft for that one.
Okay.
PowerPoint just crashed.
What was I saying? Yes, no GraphQL, no gRPC, because basically I don't have any real meaningful experience with it. There's a third point that I've forgotten. The fourth point is that this talk is not about having a go at Optus. I don't want to emphasize it now. I first prepared this talk before I started working at 2 degrees, but now that I'm at a telco, there we go, thank you. I doubly want to say that it's not about having a dig at them, it's about trying to learn from the mishap that happened to them and, when it happened to us. Unfortunately, I remember the other points there. So another point I'll make is I'm going to assume for the talk that you must retain whatever data that you've, personally identified information that you're storing. Obviously, the best way to avoid such problems of data leaking out is just not to collect or store that data in the first place if you can avoid it. So I'm going to assume that you have some sort of legal or business requirement that absolutely means you have to know, we'll just collect all the data because AI will magically make it useful in the future. You're actually, there's some real requirement you have to hold on to it for. And there's another point which I've completely forgotten. It comes back in a second. This whole presentation works a heck of a lot better if it does. Good point. Yes, the other point I was going to make was that none of what I say today here is original to me. It's all, stuff that's out there elsewhere. Like you can go look at the OWASP API top 10 and you get much same information. This isn't things I figured out. These are things that I learned listening to others talking about such matters. All right, while we wait for that to come back, I'll start giving you the brief rundown on what happened to Optus. So basically, about September last year, Optus had a problem where there were basically reports in the media saying, oh, hang on, all of your, it was 10 million customer details supposedly being collected from someone, by someone from an Optus API REST endpoint, and they're trying to sell it on the dark web. And, obviously this is a problem. I think that's the next part of that. So, yeah. So the important part of it all basically was that the person who was trying to sell it had said, oh, well, I collected this all from like an API endpoint that was returning real customer data but had absolutely no authentication requirements. I could just come along and ping it. So it sounded like probably just someone had come along and scraped it off Shodan or found, on Shodan, looked at it and was like, oh, okay, this is interesting. So they leaked the 10,000 record subset as proof that they had, and, the media in Australia looked into it and said, yes, looks legit. And Bush pointed out 10 million people is about a third of the entire population of Australia. So, it's a pretty big number of records. So then what happened was, of course, the CEO of Optus, who resigned last week because of the thing that happened last week. Not this one, but that sort of didn't help. That they said, oh, this is a very sophisticated attack, blah, blah, blah. And what happened was a couple of days later, you had the Australian Minister for Home Affairs, who also covers cybersecurity as part of their portfolio, the federal minister, actually, on TV. An interviewer said to them, oh, you don't seem to be agreeing that this was a highly sophisticated attack. And the minister basically said, well, it wasn't, so no. Which is pretty much as direct a, dig at the Optus people as he can make, basically calling them incompetent liars. It was not very good. Oh, there we go, that's the one. Pretty much, yeah. Let me just double check my points from the last slide when I get it working again. Did I turn the clicker off? No, it's on. Oh, okay, now the clicker's not working. Yeah. Pretty much the point was that this all happened in the minister didn't like it. Next slide, please. Someone can press that. Is anyone able to change the slide? There we go. Okay, cool, right. So what happened was the all this media and government attention that got onto this, because it really got a lot of attention. They spooked this person. They took down all the records they had up and kind of sort of apologized. And they said, oh, well, there's no security.txt in the website, so I couldn't report the vulnerability, and therefore I decided to go try to sell it on the dark web instead, because, one totally leads the other. And Optus got a bit lucky because shortly thereafter, the Medibank breach took focus away. But I know when this all happened last year, the Risky Viz podcast people said, oh, it sort of sounded like someone who phoned up this person's mum and said, told them what was going on. And it really sounded like that to me as well. The point is, even though in the end there's only 10,000 records leaked only, and, it wasn't super bad, it was still pretty damn bad because it was like, front page of the newspaper news. The federal minister basically called them incompetent liars. So all that happened and wasn't good. Next slide, please. Right, okay. So some thoughts from me about this. Slide, please. So how did it happen? I honestly have, no inside knowledge. My best guess, based on what I read in the media, was that basically someone probably turned off the authentication requirements for a particular API endpoint while they were testing or something, and then just forgot to turn it back on, which, unfortunately can happen. And what that suggests to me is that there's probably some sort of organizational structural failure going on in the organization, because, basically it shouldn't have been that there's something saying you don't have just, proper endpoints exposed to authentication requirements. That suggests to me there's probably no relevant policy saying don't do this, or no one was actually enforcing it. And if you don't enforce the policies, you basically might as well not have them. So the point is that, one developer having one bad day, it's a lot more bad days for a lot of people. It's still not. Hang on, let me try to turn this off and on. Let's see. Did that work? No. Well, I don't know what's going on. Next slide, please. Right. The thing I want to emphasize at this point is that we shouldn't sit around and try to, point fingers and blame people. You don't say, who was the idiot who did this? Some stupid dev didn't do their job. The reviewer should have caught it, or the tester should have caught it. Basically, it should be very difficult for one person, not doing everything perfectly for it to happen. Basically, it's just to me that if, all it took was one person forgetting one thing for a second for all this to happen, then that's just me that there's something bigger going on. So my point is, you shouldn't try to find a scapegoat. You should investigate what process led to the failure and try to improve that. And then, if it was like an unenforced policy, actually enforce it. Next slide, please. Right. Okay. So now we get to the sort of meat of this talk. Me basically explaining a few different techniques, I don't know what you call it, about how you can try to prevent this happening to you. So next slide, please. Right. So the most important one is to deny by default. So always deny access to your endpoints by default. Very slight caveat. So thanks. So all unauthenticated access must be explicitly in the code. So deny by default means two things. So it means that, obviously anyone who turns up without credentials gets turned away, but also it means that all times that people can access something without authentication, it must be marked explicitly. If there's nothing saying, you need this level of authorization to access it, then no one gets access to it. And what happens there basically is that, one, it means pretty obvious if you've got something marked saying this will be allowed to anyone who's unauthenticated, people can look and be like, okay, that doesn't seem right. Secondly, it means that if someone's forgotten to, put authentication requirements on, then no one can get access to it. And what happens is it goes out and you say, okay, your customers start getting, like back a 4 or 3 saying you're not authorized or whatever. But it's so much better that happens. Your customers ring you up, 9 a.m. in the morning and say, hang on, your endpoint's suddenly gone funny. And then you get it fixed, a few minutes later and everything's fine. So much better that happens than all the information leaks out. And, a few months later, you're told, yeah, you've just leaked 10 million customers' records. So do that, basically. And it makes it a lot easier to stop these things happening. And of course, you need to make an exception for things that are like your login endpoint, because it's pretty hard to log in if you're not really, if you don't do that, then you can't log in if you're not doing it. So things like that, or, password reset, sign the password reset flow, those obviously have to be authenticated. So next slide, please. Right. So to reiterate, because this thing is so important and so useful, always deny by default. If you remember one thing from the talk, make it that. It's pretty much the best thing you can do to stop the stuff leaking out. That stops the vast majority of unsophisticated attacks and will make more sophisticated attackers frustrated, which it may not completely stop them, but, slow them down and tease them off. And to be honest, if you're too hard to crack, most people are going to look elsewhere. Probably for most organizations, not all, but most, you're not actually getting targeted specifically. So, it'll be fine for you. If you sort of, it takes them a week and they're not getting anywhere, they're probably just going to move on, to be honest. So if you do that, you're going to be pretty good. Next slide, please. So the next thing you can do is get your developers to be doing code reviews. Hopefully at this point, you'll be saying, well, duh, anyone who does development, who doesn't do code reviews these days. And so one of the great things about deny by default that I said before is when your people are doing code reviews, they come along and find an endpoint that says, unauthenticated access allowed, and it's handing out customer data. Your developer will look at them and be like, hang on, this doesn't seem right, and question it. At least you hope so. And so if you have those two together, it's going to stop these things happening probably 99.9% of the time, because, one person might forget, but a second person comes along and looks at it and is going to think that's a bit funny. Of course, you want to try to ensure that code reviewers actually understand the broader context of what's going on. When some unintended changes happen from intended ones, not always possible, but if you can get someone who knows the code base to look at it at least, because, sometimes the new person they have no idea that changing X suddenly affect Y over there in some weird way that, only somebody who's experienced the code base will know. An important part is to make review approvals mandatory, so you have protected branches, which, GitHub supports. I'm pretty sure GitLab supports. I'm pretty sure other systems support it as well. That way people can't just go, oh, well, review didn't like it, too bad, I'm just going to merge it anyway, and now it goes in production. Next slide, please. So the next part is to ban changes in production. So what I mean by that is that you don't have someone just, goes into the actual running live script and says, okay, I'll just tweak this here and tweak that there, and, we'll just fix things in production right now. So there's a few reasons for that. The first thing is, of course, it dodges all the code review that we just said is really important. So if you can, have a CI/CD process, preferably one where you can have some way to deploy it fast, and only deploy from those protected branches that people can't go, oh, well, I'm just going to make this one change real quick, and, then bad things happen because there may be some mistake somewhere and no one got reviewed it. So another reason not to do this is that someone fixes something in production, and then that change doesn't get propagated back into the code base, and as soon as you do a new deploy, that's it, that fix is wiped out, and you're back to the same problem. Or people make some sort of temporary change to, make things work briefly, probably allowing unauthenticated access, and then, it happened last thing Friday afternoon as the fix to get things running again, and by Monday morning they've completely forgotten they're supposed to come back and fix it, and, 3 months later it's still there potentially. Maybe. Of course, there's also no guarantee that there won't be someone malicious just happen to look at that endpoint right at that moment when suddenly it's been allowed, unauthenticated access is allowed for a moment. So, that's another problem. It's probably only going to be an issue in dynamic languages because, most static languages, you have to go through the full deployment process to get it out. But, there's a lot of PHP and Python and that out there, so it's still potentially a problem. Right, next slide, please. Cool. Okay, so the next thing you can do. The formal name is control validation testing. I just call it automated exposure testing, same diff in this case. So you already have lots of automated tests, right? Unit tests, end-to-end tests, integration tests, all that sort of thing. So you can basically just make a few more, or all you do is just send some requests to your test system and check the responses and say, okay, we've got these things that basically we just sit there and send a command, send an access request of no authentication, we should get back a 401. We send it with basic user, but this is an admin endpoint, we should get back a 403, that sort of thing. Just do that and check that you're getting back the expected response. And then, okay, we've got the admin user, we should be getting a 200. Oh no, we're still getting a 403. Okay, someone probably forgot to put any authentication requirement on that because you're using denied by default, because you had nothing, no one can get it. So it can be just as simple as that, and that can do a lot. In my old job, we did this sort of thing, and it stopped us. Despite everything else we did, it stopped us pushing out a change like that. We were going to expose something inappropriately at least once, where they came back and went, "Oh, that's funny. How did we all miss that?" So it does work. It does help. And to be honest, a lot of the tools out there can do this. Your Dash tools, things like Postman or something, I think. And to be honest, I'm pretty sure you could just do the curl on a shell script if you really wanted. I wouldn't recommend doing that way, but if you just want to do something really quick and dirty, I'm pretty sure you could do that and, just say, okay, we get back for a 1. Boom. Done. Right, next slide, please. Rate limiting. Okay, so the thing about rate limiting is you can't always do it. So I figured out, I've just, supposedly leaked potentially 10 million records, just a second. All right. And so I sat down and did the numbers. And if they did 10 million records, they're getting 1 record per second leaked out. That takes about 16.5 weeks to get up to 10 million records. There's some suggestions only 2 million. But even so, that'd be, over 3 weeks. So the conclusion is that the endpoint that they were using probably was not heavily rate limited at all. In fact, I believe the security team at Optus eventually caught this because there was this giant spike in requests to the endpoint. But, it took them hours before they noticed that and stopped it. And during that time, the person scraped millions of records. Basically, use rate limiting wherever you can. All good frameworks should have support for it. Web frameworks, I should say. If your web framework doesn't have support for rate limiting yet, it probably isn't mature enough to be used as your production system, basically. Because if it doesn't have rate limiting, it probably doesn't have other things. And it could be good in a while, but not yet. And obviously, you can't always do rate limiting. You might have some endpoint that's just, legitimately constantly getting slammed by the same customers and what have you. But if you can do it, put it in, because it can make the difference between 10,000 and 10 million records leaking. And both suck. But one sort of, maybe you get like a brief mention, someone in the back of the Herald or whatever, or the newspaper, whichever one you're in, from Auckland to always in the Herald. Or you get 10 million, and then it's, front page news and leading of the 6 o'clock news headline sort of thing, and, ministers on TV slagging you off for it. So if you can do it, because it can make a huge difference when something does happen, because of course, eventually something always happens, sadly. And if you really say, oh, well, we want to do this, but we've got like 2 users that hit us like 500 times a second and everyone else is, twice a second at most or something, and make an exception for those 2. Say, okay, maximum of 5 per second for everyone else. But these 2 will say, you can do 600 or something. And if your system's done well, that should work still. And then everyone's happy, and you're not going to leak it because some random person who's not got a proper, customer account comes along and finds it. Right, next slide, please. Okay, so IP address allows, I say IP address, but basically anything you can use to identify the relevant users. So basically, the users are only going to be connecting from some fixed origin. So, for instance, a corporate network, then only ever allow those origins to connect. So anyone else not coming from that origin, you just don't even talk back to them. You don't acknowledge it. They send something to you. You don't acknowledge it. You just never respond. So if you've got 2 open networks, or you've got certain fixed IP addresses that people are going to be accessing from, like at my old job, one of our internal-only systems, one of the developers had he paid extra for static IP address with his ISP, and so that was whitelisted. I didn't actually like that. I wouldn't have gone with that, but we can be pretty sure if it came from that IP address, it was probably legitimate because it's probably him. And this actually works really good when you have different customers on different instances, because then if one customer somehow, tries to go into another customer's instance, they're not necessarily actually going to be able to find anything. Like they go, okay, I'll just take my creds and go over there and even have it talk back to them. So obviously this isn't always possible if you've got some endpoint that has to be open just anybody who, anyone can go to the website, sign up and start accessing it or whatever. You can't do that. But where you can do it because, if someone can't even get your instance talking to them, it's very hard for them to get any further. Right, next slide, please. Okay, so I'm pretty sure this is the last one for today. Last but not least, get some security training for your developers. So lots of devs are self-taught these days. Even people with comp sci or software engineering degrees don't necessarily get taught security. I know when I did my undergrad comp sci, I didn't have security in it whatsoever. And what this often means is that, developers, they know how to do React and Vue and all, fancy development things, but they just don't know security. What that means is security problems can be unknown, so they don't even, there's a problem they don't even know, like, that there's a gap in their knowledge. And these are the most dangerous type because people don't realize there's an issue there. And so what happens when you get some security training for your developers and sending them to an event like this is a great start. Not the end, but a great start. They just learn, okay, they just learn a bit about these security things and know, okay, this is the sort of thing that makes a problem occur. And so they might say, okay, I don't know what the fix is. I don't even know if for sure it's a problem, but this smells like a problem to me. I'm going to raise it and go get some help from someone who knows what they're talking about. And basically what you get is, someone intercepts it and cuts off a security problem before it gets out. Whereas before they might have just been like, oh, I don't see any problem, off production. And you don't even need all that much training. You get quite a lot of benefit because once people start to learn what things are, like SQL injections, for instance. In fact, I've got a great example. My first programming job was an internship like 10 years ago now. And part of that involved going through every line of the code base of this company's product, pulling out hard-coded strings. And what I saw quite often was, hard-coded SQL queries would be like, select star from O string plus, use a variable plus carry on the rest of the SQL query. And of course, being I'd just done some undergrad comp sci at the time, I didn't realize this is a problem. Now, after going to like my first security conference, I was like, hang on, that would be a massive problem in hindsight. But fortunately, in this case, it was desktop applications. People basically just hacked themselves, so it wasn't as bad. Still not great. But the point was, I had no idea back in the day that was an issue. And after going to one conference, I would have been like, oh, hang on, wait, this doesn't seem right. So the point is, even just a little bit of training can actually go a long way to help people just have that sense of when something looks like it's an issue and be able to raise it to the person who is supposed to know what they're talking about and get some help. And that can help me prevent, bigger issues getting out because people don't necessarily affect themselves, but they can get the help they need before it goes to production. Right, next slide, please. Okay, so sum up, because I'm pretty sure we've gone over my time already. Next slide, please. Basically, what happened was about September last year, the data of millions of Optus customers was leaked. Optus, not Optus. Customers was accessed by some outsider, and they said that they scraped it from a REST API endpoint with no authorization, authentication requirement, which the federal minister basically confirmed and all but directly confirmed. And, Optus got slagged off by the said minister on TV. So Optus was actually a bit lucky because most of the data that was scraped actually wasn't leaked in the end. There's only 2,000 records. And the big Medibank hack that occurred about 2 weeks later actually distracted everyone. The Optus one kind of got forgotten until last week when they had huge problems. But even then, it was, serious cost of money, reputation, and eventually the CEO's job because two big clangers in about the space of a year pretty much made a position untenable. Next slide, please. Right. So a point I want to emphasize here is that when these things happen, you fix the problems, you don't point fingers. Pointing, sitting around pointing fingers, doing, I think they call it blame storming. That sort of thing basically just, it doesn't help. It gets no one anywhere. In fact, probably the problems go unaddressed because everybody's busily trying to cover their own butt. So basically, what happened, I think, not knowing anything myself, that probably some lone developer made a single mistake one day, trying to get something working. And that led to an open endpoint, and that led to all the stuff getting scraped and all that sort of thing. And it should be very difficult for that one single mistake to lead to all this. What it says to me is that there's probably some sort of larger structural organizational issues. And, if you're like a 3-person outfit, okay, but something the size of Optus, which I think, makes 2 degrees look tiny, like they should have the resources to be able to handle this sort of stuff. It says to me that there's probably some sort of organizational structural issue making problems there's probably some sort of gap in the processes or procedures or policies or enforcement, all that sort of thing. And so what that says to me is that if you do have to blame someone, it's probably actually more management who, we're making sure that procedures are followed and that sort of thing, rather than, the intern in the corner who genuinely doesn't know better. So yeah, basically don't sit around pointing fingers, find the problem, fix it, and then say, how can we prevent it from occurring again? Right. Next slide, please. And so I just want to point out, okay, so there's no one defense that's going to stop, all breaches. And unfortunately, given a persistent enough attacker with enough resources, eventually they'll get in because it's always social engineering. But the more defenses you have, the better, because then if one of them somehow fails temporarily, another stops it. And you say, and usually, occasionally you can have those defenses either conflict with each other or have such a bad performance problem that, you can't actually keep them. But 90% of the time, the more the better. And of course, another point is that some of these are technical things, some of them more structural or cultural issues. And so these are actually implemented, as it were, by different people. So it's not just, the two devs, it's all them. No, the manager also needs to be involved to make sure that, some higher level stuff gets done as well. Next slide, please. Right. So just to recap the different approaches that I said you can use. So deny by default, always deny by default. That means both, people with no creds just get told to go away, but also that any endpoint that hasn't had explicitly given the authentication authorization requirements, nobody gets to it. And then what that means is you have your customers ring you up, in the morning and say your endpoint's suddenly acting funny, rather than 3 months later you find out you've leaked 1 million records. That was great, but one's a heck of a lot less problematic than the other. Code reviews, just, get your developers to do code reviews, and hopefully they'll understand the context of it. Hopefully they'll understand security issues. And when you're doing deny by default, if someone finds that, the give back customer details endpoint suddenly says unauthenticated access, someone will probably look at them and be like, this doesn't quite seem right, and can question it. Don't make changes in production. They tend to lead to problems that don't get fixed. Like they fix the immediate issue, but then they don't end up actually fixing the long-term issue. And of course, if you make things relax security requirements temporarily, one, people forget to revert them, and two, just have to look at that moment. Control validation testing. A great thing you can do is basically just ping your own endpoints and say, okay, are we getting back the correct, 401s, 403s, 200s, whatever status codes for these endpoints, depending on the user that we've got. And there are lots of ways you can do that if you want. Rate limiting. If people don't need to be accessing 1,000 records a second, don't let them access 1,000 records a second. Basically find the maximum that's sort of going to be legitimate and try to cut it off at there. And if you've got a couple of customers, who are exceptions, then make exceptions for them. And that doesn't prevent stuff from leaking out, but it can prevent the scope of it leaking out and, make a huge difference in basically how much of a problem it is in the long run. IP address allow listing or any relevant data about your clients. Basically, if you know only certain people are going to be accessing the endpoint, legitimately, then only respond to those people and just ignore everyone else. It can't always be done, but if you can do it, because if people can't actually access the endpoint, it's pretty hard to get any information out of it. And lastly, get security training for your developers. A good start is to send them KubeCon or OS Day up in Auckland, or QuakeCon when it comes back. They're all good. So send them to one of those, send them to the trainings beforehand, and hint. Other training is, I know for a fact there are people in the room who will happily provide training to developers, pay them. And it doesn't necessarily teach them how to be the world expert on AppSec, but it can help them learn to spot where problems are and raise them so that someone else can help them fix them. And I'm still not working. Next slide, please. Right, so that's basically my talk. So just one thing to remember from all my talk is, if in doubt, just say no, by which I mean deny by default.
I am a super genius.